All right, let's jump right in. Welcome to this explainer. Think of this as your ultimate exam-ready masterclass for CM1 Chapter 3, Real and Money Interest Rates. Now, if you've been working through your financial math, you already know how to move money through time. But today we're adding the absolute most important real-world dimension. What actually happens when the value of the money itself is changing? Think about this real-world scenario for a second. Let's say you just got a 5% raise at work. Sounds pretty fantastic, right? Well, hold on. What if inflation, meaning the prices of things in the economy, is running at 7%? Your salary went up on paper, sure, but the cost of literally everything you buy is going up even faster. So, in terms of what your money can actually purchase, your true purchasing power just dropped by roughly 2%. We call this the inflation illusion. You feel a bit richer, but quietly, you're actually getting poorer. So here's our roadmap for today. We'll start with the inflation illusion, decode the Fisher equation, tackle real versus money discounting, walk through some actual exam questions, and finally, navigate the exam mistakes minefield. Miss this distinction, and every financial calculation you ever do will be quietly, dangerously wrong. You know, that quote perfectly captures the stakes of Chapter 3. If you miss this, you might know exactly how many pounds a future payment is worth on paper, but you'll have absolutely no clue if those pounds will buy you a house or, well, just a sandwich. Stripping out that inflationary illusion is literally the only way to see the true economic value of a cash flow. Okay, Section 1, the Big Three. Let's define our core rates. First up, we have the money rate. We denote this with a lowercase I. You might also hear it called the nominal rate. This is the headline rate your bank quotes you, measuring exactly how fast your raw pounds and pence are growing. I want you to think of the money rate like the speedometer of a car. It tells you exactly how fast your wheels are spinning relative to the ground beneath you. Second, we have the inflation rate, which gets the letter J. This is the percentage by which the general average price level of goods and services goes up per period. Going back to our car analogy, imagine your car is driving on one of those moving walkways at the airport. Inflation is basically the speed of that walkway carrying all the prices forward. It's silently eroding what your money can actually buy. And third, the all-important real rate of interest. We call this I prime. This is the exact rate at which your true purchasing power grows. It's your actual speed relative to that moving walkway, not just the ground. Forget the raw number of pounds for a second. This rate tells you how much more actual stuff you can buy next year compared to today. It's the only metric that reveals if you're genuinely getting wealthier. Moving on to Section 2, the Fisher equation decoded. This is the master formula of Chapter 3. All right, take a look at this. On the left, we have the exact form. 1 plus the money rate equals 1 plus the real rate, multiplied by 1 plus the inflation rate. Notice that it is multiplicative, not additive. Over on the right is the approximation, which basically says the money rate is roughly the real rate plus inflation. But why is the exact form multiplicative? Well, because inflation compounds. When prices rise, you need that extra percentage on your entire accumulated amount, not just the original principal. Let me be super clear here. Using that additive approximation for an exact calculation in an exam is a guaranteed way to drop marks. Don't do it. So, if a question asks you for the real rate, please don't just subtract the rates. We need to think in growth factors. 1 plus the rate is a growth factor. To isolate one, you just divide by the other. In plain English, it looks like this. Your real rate equals your money growth factor divided by your inflation growth factor minus 1. It's simple, it's elegant, and it's foolproof once you see it like that. Section 3, the discounting crossroads. Let's talk real versus money discounting. Imagine a friend promises to pay you £1,000 in 3 years' time. How do we figure out what that's worth in today's purchasing power? We arrive at a sort of discounting crossroads where two totally distinct paths actually lead to the exact same destination. But before we walk down either of those paths, I need to issue a massive warning. This right here is the cardinal sin of Chapter 3. Never mix your terms. If you have a money cash flow, meaning the actual raw pounds printed on a check, you absolutely must discount it using the money rate. But if you have a real cash flow, one that's been adjusted for inflation, you must discount it using the real rate. Mixing these up will completely destroy your calculation. So here are your two paths. You can work entirely in money terms, take your inflated money cash flow and discount it at the money rate I, or you can work entirely in real terms, take your deflated cash flow, meaning its actual purchasing power, and discount it at the real rate I prime. Because of that Fisher equation tying the whole universe together, both methods give you the exact same identical present value.
Just match your terms, and you really can't fail.
Section 4. Solving exam questions. Let's look at some step-by-step archetypes.
All right, let's look at archetype 1. This is a classic, virtually guaranteed exam question. You're given a money rate of 8% and an inflation rate of 3%. Your task? Calculate the exact real rate of return. You have 2 of the 3 Fisher variables, and you just need to find the third.
We can crack this with a simple 4-step framework. Step 1, lock in those variables. I is 0.08, J is 0.03. Step 2, mentally note your exact Fisher equation. Step 3, rearrange it to solve for I prime by dividing those growth factors we talked about. And step 4, just execute the math. 1.08 divided by 1.03 minus 1. That gives us 0.04854, or roughly 4.85%. It really is that straightforward when you break it down. But wait, how do you actually know you didn't accidentally press a wrong button on the calculator? You use the 3-second sanity check. Just ask yourself, is my exact calculated real rate slightly lower than the simple approximation? Well, 8% minus 3% is 5%. Our exact answer was 4.85%. Because of that cross-product compounding effect we broke down earlier, the exact rate should always be slightly less than the approximation. It is, so we know for sure our math is rock solid. Now let's level up to archetype 4. This is a much harder, multi-chapter style question. Let's say a pension pays £15,000 a year, but it increases each year with 2.5% inflation. The money rate is 6%. We need to find the present value for 25 years. Now, because that actual payment amount changes every single year, trying to project each individual money cash flow sounds like an absolute nightmare, right? Well, here is the massive shortcut. Because the payment increases perfectly in line with inflation, its real purchasing power never actually changes. It's effectively a level real cash flow of exactly £15,000. So, step 1, identify that real payment. Step 2, use Fisher to compute your real rate, I prime. That's 1.06 divided by 1.025, minus 1, giving us 3.415%. Step 3, grab your standard annuity formula for 25 years, but calculate it using that newly found real rate of 3.415%. Finally, step 4, just multiply £15,000 by that annuity factor. Boom. You just bypassed a massive headache by choosing to work entirely in real terms. Section 5, the minefield. Let's talk about avoiding common exam mistakes. I want you to keep these absolute rules burned into your head. Never use the additive approximation when an exact calculation is required. Never commit the cardinal sin of mixing real cash flows with money discount rates. Also, be on high alert for the Chapter 2 trap. If they hand you a nominal rate compounded quarterly, you absolutely must convert it to an effective annual rate before you even think about applying the Fisher equation. And lastly, if a question specifically says payments in today's prices, pay attention. That means it's already a real cash flow. Don't deflate it again. That's called double deflation, and it will artificially shrink your numbers and ruin your answer. Frequently, exams will hit you with a state the assumptions underlying your calculation question. Honestly, go ahead and pause the explainer right now to take a screenshot of this for your study notes. It's your master checklist. For these calculations, we are assuming constant inflation, a constant money rate, a single general price index, that the exact Fisher equation holds completely true, and that we are blissfully ignoring taxes. So why does mastering all of this matter quite so much? One word: Chapter 10. Everything we've discussed today about the Fisher equation and valuing inflation-linked annuities feeds directly into Chapter 10, which covers the valuation of index-linked bonds. If you own the concepts in Chapter 3, Chapter 10 is going to feel incredibly intuitive. I want to leave you with one final kind of provocative thought. We almost always assume prices go up. But what if we hit deflation? What if the inflation rate actually turns negative? According to the Fisher equation, if prices are falling, your real return, your actual purchasing power, could technically be higher than your quoted money rate. Think about the math on that. Your money buys more just by sitting there doing nothing. Keep that concept in your back pocket as you tackle your practice questions. Thanks so much for joining me on this explainer, and I'll see you in the next one.